Howdy everyone. Still making some good progress on the avionics installation. So I just want to go over real quick a couple of, well, I don't know if a couple, a feature that I've just learned about with my backup power supply. So here's my setup. I have a new power supply actually. The power supply that I had been using, I didn't realize only went up to about 2.5 to 3 amps. This one goes up to 12, and I need something more than 3 amps because when the backup battery is needing recharging, it recharges through this power supply at the moment, and sometimes it requires more than a couple of 3 amps. So this is my current setup. So this is the new power supply. On the right, I doubt that you'll be able to see any of this, but on the right is the volts. I've got it set to about 13 volts, a little low. These systems, when they're operating on a full charge or with an alternator, they should be closer to 14, 14.2, something like that. 13 volts, and this meter here is my amp meter. What's nice about this power supply is it has a push button. You can push that button in and hold it and then adjust your max current, so it will not go above that max setting. But anyway, you can see right now that it is, what is that? It's about 1 amp at the moment. And that is because I've got the main power on already. So I basically have power going to the VPX, and it's distributing power to the backup power supply and things of that nature. So I'm going to turn the main power off, and you will see now potentially that the amps are 0. Like I said, I don't know if you'll be able to see this or not, but that sweepy needle on the left is the amps, and it's at 0. So obviously with the master off, there is absolutely no current being consumed. Now what I'm going to do is I'm going to connect my backup power supply, and I don't have a switch for that installed at the moment. So all I do is I take the ground wire that would normally connect to the switch, and I just ground it to basically simulate a switch that's been closed. I'm doing this one-handed. I'm not really paying attention to what the camera's filming, so excuse that. So now I have the backup battery is now simulated with the switch to be turned on. And I have that directly connected to my EFIS as a backup power supply. And I also have the main power for the EFIS hooked up to the main power supply. But like I showed you a moment ago, the master switch is off, so according to my DC power supply, there are no amps being drawn. I just connected the backup power supply, and it is, as you can see, is now providing power to the EFIS. So now, obviously, if I disconnect the backup power supply, if I, in effect, turn the switch off, I lose power. So that is what I want. So now let me go back. Again, I'm doing this one-handed. I'm not really sure what the video camera is filming. I'm going to reconnect my backup power supply. Okay, so now I've, in effect, turned on my backup battery, and it takes about 30 seconds or so. It will power up the EFIS, and of course the main power, which is simulated with this power supply here, is still showing no amps, which is correct because I don't have the master switch turned on at all. You can see on my VPX, there are lights that flash down here by the Ethernet cable. There is no power there. So everything is turned off except for the backup power supply. And now my EFIS is back up and running. There we go. So I know that the backup power supply by itself works. Now, another cool feature that I didn't realize that this battery has with the internal electronics, it has what is called pass-through circuitry. Basically what that is, it's an option. You don't have to have it connected, but what this thing will do when you have your pass-through connections made, it allows power from your main battery to pass through the circuitry in this battery, and it will pass it along to whatever you have it connected to. So with the main power turned off, whatever's connected to this backup battery is only powered by the backup battery. When I turn the main power on, that power gets passed through this backup battery to whatever is connected to the backup battery. And it also, no, that's not true. So that's all it does. When you have your main power source turned on, the power from it will pass through the backup battery onto whatever is connected to the backup battery. So right now I only have my ethos connected to the backup battery. Right now the ethos is being completely driven only by the backup battery. When I turn the main power on, main power will flow through the backup battery and into the ethos. So at that point, if I turn the backup battery off, the ethos will still be on because main power is being passed through this and into the ethos. So I'll do that now. I'll turn on the main power, and you'll see that needle probably not move. So there it goes. It's up to about 2.5 amps. And a portion of that is because the VPX is powering up. You can see the flashing LEDs now. And it is also providing power to the ethos. And it is also now charging this backup battery. I hope all this jibber jabber makes sense. And you'll see as things power up and they get into a stable condition, and as this battery continues to charge, the total amps will start to drop. So now the ethos is being powered by the primary source, which goes through the backup battery circuitry to power. So now if I disconnect the backup battery, if I in effect take the switch to the backup battery and turn it off, 1, 2, 3, the ethos stays on. So now the ethos is being powered from the main power source, but the power is flowing through the backup battery through those feed-through circuits. So I hope that makes sense. It's a really nice feature because like my engine information system, the EIS, which is this box here, that is also going to have backup power. But that unit does not have dual inputs for power. It does not have a primary and a backup power input. It only has one power input. So what I'm going to do is, just like I did with the ethos, I'm going to run a feed-through circuit, a feed-through connection through my backup battery, and then from the backup battery, I'm going to make the connection to the EIS. What that will do is when I have main power working, it will pass through the backup battery and power the EIS. If that backup power drops below 9 volts or 9.5 volts, this circuitry will sense that and it will automatically switch over to this power supply and continue to power the EIS. So it's a really nice feature. If you have something that does not have a primary and a secondary input for power, you can use the pass-through circuitry on this particular backup power supply. And it will allow main power to pass through it. It will monitor that main power, and when it drops below a certain setting, it will automatically power the instruments that are connected to it. In this particular system, you can connect 4 individual units to it. So I'm definitely powering my EFIS. I will definitely power my little Dynon D3 pocket EFIS from the battery, and my EIS, my engine information system, is also going to be powered through the backup battery. So that means I've got one more connection I could make, and I've considered maybe powering the VPX on the backup, but obviously the more systems you connect to it, the shorter amount of time you'll get out of it for power. So if I want an hour's worth of backup power, I probably shouldn't have 4 things connected to it, because that would just draw it down pretty quick. But I'm not there yet. I just kind of wanted to explain how this little system works. And again, I just learned about that a couple of days ago as I was reading through the installation manual yet again. As I'm actually getting into the wiring, I read and reread the manuals over and over, and things start to make sense, and you start to realize the different ways you can connect stuff and the different functions that these different devices can provide. So everything works great. This will work off of backup power alone. It will work off the main power. And if the main power drops below a certain voltage, the backup battery automatically kicks in. One thing, and this is all discussed in the manual for the backup battery, it's discussed in detail in the manual. In order for the backup battery to supply backup power to your unit, you have to have the backup battery turned on. To have power passed through the backup battery to your unit, you do not have to have the switch on. As long as your main power is on, it will run through the battery and into your system, into your unit. If that main power supply fails, then obviously you have nothing passing through and your unit will shut down. If you want to run on backup battery power at that point, you have to turn your switch on. But if you leave the switch on, as soon as the pass-through power drops below 9 volts, it automatically will switch over, and you won't see anything change with your component that's connected to it. I hope that makes sense. It's probably as clear as mud, but anywho, the point is I'm making progress. You can see now I have my EFIS powered up, and I'm getting pretty excited. So I'm going to continue on. Again, I still have switches I need to do. I still got my comm radio and my transponder, and I've got to work on my EIS, and I still got, I've got miscellaneous wire bundles at different places that still need to be connected. So a lot of work to do. I'm going to get at it, and I'll talk to you guys later.